Let's continue our study of changing primitive data by examining the problem of swapping and rotating data. Here's the problem statement. Suppose you have two double values, first and second. How do you swap their values? Now what I mean by this is if first contained 2.1 and second contained 3.2 initially, how would you change it so first would contain 3.2 and second would contain 2.1 at the end? Well, here's the obvious, but unfortunately wrong answer. We declare first as a double equal to 2.1, declare second as a double equal to 3.2, and then we'd say first equals second and second equals first. That should work, right? Well, this is a very serious misunderstanding of an assignment statement. Just for your knowledge, assignment statements are one of the tricky things to get used to initially in computer programming. So this is something where you should really focus your attention right now. Let's take a look at what happens with those statements using a memory diagram to identify the problem. Well, first contains 2.1. So remember, first gets its own box because it's a double. Second contains 3.2. Now when we say first equals second, what we do is we take the value that's in second and we copy it to first. So the value that's in first is gone forever. We cannot get it back. And the value in second now sits in first. So if you look at this point, we have two copies of 3.2 and no copies of 2.1. So when we try to do second equals first to get that 2.1 back, it doesn't work. All that happens is that 3.2 is copied to second. Well, second is already 3.2, so that simply cannot work. So swapping values is like swapping two big heavy balls that are in your hands. You could juggle them, but the problem is we can't toss anything into the air because there is no air in a computer program. You could set a ball on a table, but we don't have a table either. So all we have is variables. What this means is that we have to create another variable to store one of the values. There is absolutely positively no other way to swap values. So here's the trick. We need some place to store one of the values temporarily. I usually call this temp, so we declare a double temp. Now we copy one of the values to the temporary location. So that would be, for example, temp equals first. That means take the value in first and store it to the location temp. Now we can replace the value stored in the temporary location with the other value. So we could say, for example, second equals first. This takes the value in second and overwrites the value in first. Now the reason we don't have the problem that we had previously is because we've saved the value in first to temp, so we still have it. Then what we do is copy the temporary value to its final location. So second equals temp. So now we get second from the location temp. Now this exercise is a real test of assignment statements. Assignment statements do not work like equality in math. Remember, the right-hand sides and the left-hand sides are different. So the value on the right is stored in the location on the left. This is a real problem right at the start in programming. Assignment dyslexia, where you confuse the right-hand and left-hand sides, is a very common problem in programming, and one that it takes some people some time to get over. So saying first equals second and second equals first is not the same thing. First equals second means take the value in second and store it in the location first. Second equals first means take the value stored in first and put it in the location second. These are completely different things. And so you really have to concentrate on what it means to be on the right-hand side versus the left-hand side. The other thing to remember here, this is not an equality statement. This is a Java operator, not a mathematical operator. One of the things to know about these little programming tricks that I'm going to show you is that I don't think I ever would have thought of that if somebody hadn't shown it to me first. I learned it from someone in a beginning programming class a very long time ago, and he probably learned it from somebody else who learned it from somebody else. So if you didn't think of this trick, don't worry about it. None of us would have thought of this trick. Somebody showed all of us. The key is understanding the trick well enough to remember it so you can use it later. Let's think about how we might rotate three values left. Suppose we have three values, first, second, and third, and we want to rotate the values so first contains what second had, second contains what third had, and third contains what first had. Well, guess what? The exact same trick works. In fact, this is a really good way of making sure you understand the trick, is can you use it in a little different circumstance. So what we're going to do is save a value to a temporary location before overwriting it. So, first we're going to save first to a temporary value. So double temp equals first. Then we're going to give first second's value. Notice it's okay to overwrite first at this point because we've saved the value someplace else, to temp. So this is first equals second. That means take the value in second and put it in location first. Then we give second third's value. So second equals third. Take the value in third, put it in location second. Then at the end we can give third the temporary value. So that is third equals temp. Take the value in temp and set it in third. Let's show a memory diagram to make sure you understand what happened here. Here are our three variable locations, first, second, and third. Now I've just put integers in there. They could have been doubles. Doesn't really matter. So when we say temp equals first, the value in first, which is 1, gets moved into temp. Then we say first equals second. So the value 1 is removed from first, gone forever, cannot be retrieved, and the value 2 is written instead. Then second equals third. Well, that takes the value 3 from third and copies it into second. This is okay because second's value has already been moved into first. Now we take temp's value and move it into third. So in the end, we have one copy of 1, one copy of 2, one copy of 3. And in fact, if you follow along, at every point in time, there's one copy of each of these values, or more, hanging around. That's what's necessary to make swapping or rotation work correctly. Keep programming.